Hi everyone, Geek37 back with another video. This is part 19 in my Exploring the Heptagonal Triangle series. And as you can see, I have that written off to the right with all the angles, all the sides, and the circumradii drawn in because we are using all those components, and that is a picture that you should see where those parts are coming from. I didn't include that in any of my last videos, but I will include them here every so often just to remind you where all of these variables come from. Now what we're going to do today is we have the sine ratios for both pi over 7 that I derived in prior videos. And what we're going to do today is we are going to equate them to each other, and we're going to solve them in a certain way that we are going to need in the next video because I intend to do a pretty complicated calculation with them. So what we'll do is we'll square both sides and we'll get a squared over 4r squared equals 1 minus b squared over 4a squared. And of course, going further, we can find the common denominator on the right side. So we'll get 4a squared minus b squared all over 4a squared. And the nice thing about this particular these calculations, we're doing two other ones as well. On the bottom, there are 4's in both denominators, so they can be canceled off. So we are left with a squared over r squared equals 4a squared minus b squared over a squared, like so there. We can cross multiply to both sides. We'll get a to the 4th equals r squared times the quantity 4a squared minus b squared, just like so there. Okay, now let's move on to the next calculation. This over here. Okay. All right, now we are going to equate the different variable ratios and expressions for sine of 2 pi over 7. So what'll happen is we'll get b over 2r equals the square root of 1 minus c over 2b quantity squared. We'll square both sides to get rid of the radicals, so we'll get b squared over 4 r squared equals 1 minus c squared over 4b squared. Find common denominator on the right side. So we'll get 4b squared minus c squared over 4b squared, just like so here. The 4's will cancel because, again, they are in the denominator. Go over here, we will get b squared over r squared equals 4b squared minus c squared all over b squared. Cross multiply to both sides, we'll get b to the 4th equals r squared times the quantity 4b squared minus c squared, just like so here. And now we will keep that for reference there. And let's move on to the next one. All right, everyone, we are now going to equate the sines of 4 pi over 7. Now, before I go further, let me explain two things. In the radical portion over there on the right, you will see negative a over 2c. That is the cosine of 4 pi over 7, and because 4 pi over 7 is obtuse, the cosine between 90 and 180, or pi over 2 and pi, will be negative. That's why I've included it there. The prior two examples I did, they were in that similar form of the square root of 1 minus the cosine of the angle. So that's why I have set it up that way. But the nice thing here is the negative will go away when I square it. And the other thing I wanted to mention is I could have put 3 pi over 7 here because, like I said, that's integral to the study of the regular heptagon, because the heptagonal triangle is a key part of the regular heptagon, but I'm not including it here because we don't really need it to do the equating. So we'll equate both ratios, c over 2r, and then we'll equate that to the radical portion. So we'll get 1 minus, I'm going to square that, so a squared over 4c squared, and then we'll square both sides. So c squared over 4r squared equals 1 minus a squared over 4c squared. We'll find the common denominator on the right, so c squared equals 4r squared equals 4c squared minus a squared all over 4c squared. And once again, the 4's cancel because they're both in the denominator. We'll get c squared over r squared equals 4c squared minus a squared all over c squared. Cross multiply to both sides, and we'll get c to the 4th equals r squared times the quantity 4c squared minus a squared, just like that. Square that off. And let's move that over to the right side because we will need that to do the complicated calculation that I wanted to show in the next video. All right, and that will conclude this video on equating the sine ratios with its normal ratio form and its square root form, and we get a few nice relations out of it where a, b, and c are raised to the 4th power, and we have some squared variables, and of course the circumradius squared, as you can see there. All right, I hope you enjoyed this video. I enjoyed making it. This is Geek37 signing off.